Okay, well my clock just hit 1 o'clock, so we are going to get going here. Thanks everybody for joining us on a Friday afternoon. This is a little different for us. We normally hold these webinars in the middle of the week, but we thought we'd see what Fridays were like for folks, so giving this a try. Today we're going to be talking about our newest Ultraprobe and how it can improve your lubrication program. We've got Adrian Messer, our operations manager for the U.S. With us today. He's going to be taking you through everything you need to know about the new Digital Grease Caddy, and also a little bit about how ultrasound in general can be useful with your lubrication programs. So that should be exciting, and we're glad you guys joined us. UE Systems, we say this every time, we've been around for over 40 years with offices all throughout the globe, and obviously that those 40 years wouldn't be possible if we weren't constantly improving on our products, adding new products, and so obviously this new Digital Grease Caddy is just a sign of that continuous improvement. So we thought what better way to launch this new product than to turn the month of February into Lubruary, which I understand is maybe a little hard to say, but let's be honest, so is February. So we've got a whole month here dedicated to everything lubrication. We've got webinars set up every Friday, and at the end of the webinar here today we'll have those dates and the upcoming topics that we've got. So hopefully we can get everybody kind of jazzed about improving their lubrication processes in 2015, and we'll be providing resources to help you do that. So with that, just a couple housekeeping. I am recording this, so if you have to jump off, or if you've got folks that you want to listen to this later on, we will put this up on our website, so you can access that. Probably be up either later today or first thing on Monday. And you can also ask questions. We welcome those throughout the webinar. So you just type those into the little questions box, and I will flag Adrian when there's times that we need to kind of pause and get some questions answered. And then, of course, at the end, we'll save time for those questions as well. So we'll try and make this as interactive as possible with all of us spread out throughout the globe here. So let's toss the screen over to Adrian. Give us just 1 second. And Adrian, the show's yours.
All right. Well, again, welcome, and we certainly appreciate you signing on today to learn more about our Ultraprobe 401 Digital Grease Caddy. If you remember back from November, we did we did a webinar strictly on using ultrasound for condition-based lubrication, and at that time we introduced you to it, but today we're going to go into a little more detail. So just briefly, just to kind of recap what we covered back in November, and that webinar is on the website. The concept of using ultrasound for condition-based lubrication is based off of friction. So when you have a bearing that is in need of lubrication, the decibel level has increased just slightly. Not enough to kind of throw it into a failure mode to where you've started to show some wear or premature bearing fatigue or other failures, but just a little bit of friction has caused an increase in the decibel level. So what we hope to see is when we use ultrasound while we're greasing a bearing and we're watching the decibel level, as we apply grease, the grease enters the housing, there's less friction, there's less noise, so we'll start to see that decibel level dropping back down to a more steady, constant level or even a baseline level, and then we stop greasing. In turn, if we start to over-lubricate, then we start to see that decibel level gradually increasing. So if we see that, then we know to stop lubricating. But today we're going to go into a little more detail on our newest Ultraprobe that we released officially back in mid-October, I believe it was. And anytime we launch a new product or make any kind of significant changes to our software, we like to try to get these tutorial type of webinars out there. So we'll certainly have time for some questions, so feel free to ask those as we go throughout the presentation. Okay, just some overall features here of the Ultraprobe 401. We'll cover two display panels, so we've got basically a display 1 and a display 2. We'll talk about the differences there. We have some customized settings within the setup menu that we'll go through. One of the major differences between the Ultraprobe 401 and the Ultraprobe 201 that most of you are probably familiar with is the frequency tuning. The Ultraprobe 201 is on a fixed frequency, where the Ultraprobe 401 we now have the ability to adjust the frequency just like any of our other Ultraprobes that have frequency tuning. So that's a big feature. We have upload and download route capability from the UltraTrend DMS software directly into the 401. So we now have data storage here, and all that's done via the SD card, same as the Ultraprobe 15,000. Just like any of the other Ultraprobes that have data storage, we have up to 400 readings per route, or that can be collected at any given time. We can actually record the amount of the lubricant added, and we'll go into that in a little more detail when we get to that slide, but we think that's going to be a nice feature. That's something that you can add to your really your whole reliability-centered lubrication program, so you can track how much grease you're using, cost, and we'll show you we've added some additional fields in our UltraTrend DMS software that'll help you do that. We can actually store a before and after lube readings, so you can actually take up to 2 readings per point. And again, if you want to take a reading before lube and then a reading after lube, when you download that information into the DMS software, you'll then see 2 historical records for that particular point. Another thing that's really nice that I think a lot of you will like, especially if you're using the RAS sensors or the remote access sensors, since the 401 has a BNC connection, you can actually plug in those RAS sensors directly to the instrument, or if you're using the RASs in conjunction with a junction box, you can plug in from the Ultraprobe 401 up to that junction box. Lithium polymer battery, built-in LED light, just like the Ultraprobe 201. And we now have a wired and wireless headsets available. Now the 401 will come standard with the wired headset, just like the other Ultraprobes. But if you do want wireless capability, you can actually plug in an available wireless transmitter into the headset jack, and then you'll have your wireless Bluetooth headset. The Ultraprobe 15,000 now has the Bluetooth built into it, so you have a wireless headset available for your 15. But if you want to do it wirelessly with the Ultraprobe 401 or any of our other Ultraprobes, then you'll need that wireless transmitter. Okay, so what's included? Here is a picture of everything that's included with the Ultraprobe 401. So starting here with the headset at letter A, again, you can get that as a wireless option. It's just a little extra cost, but again, if you want that wireless freedom, you can do that. The Ultraprobe 401 will come with a belt-worn holster that you see at our at B. C and D, we have our traditional swivel mounts. If you want to attach it directly to a grease gun, you can do that. We have the docking station here, which we'll talk about, but that's going to be basically a point of contact for the magnetic mount transducer if you choose to use that as your location where you want to make contact. Then we have the recharger here in the top right picture here, and then your BNC connecting magnetic mount transducer, and then of course the instrument itself. All this is included with the 401. Moving on here to the features, as far as the instrument itself, you can see here we have the SD card slot. And the beauty of having removable storage like this is you have the ability to go out and collect more than just one route at a time. If you want to go out and collect several different routes at the same time, you could just have multiple SD cards with different routes loaded in there. So as soon as you take that SD card out, you just put another one in with a different route. It's going to automatically load it into the instrument, and then you can pick back up and collect data on that route, collect all that data at one time, and then go back at one time and then download that individually from each SD card. The display panel here, you can see that when we load a route into it, you'll have your machine name and point name there. We'll go over some of the things that you see there on the display. If you're familiar with the 3000, the 9000, and the 10,000, we have kind of the same concept here with this sensitivity and spin and click dial. So not only can we turn it left and right to adjust the sensitivity, but if we press and release, we can then navigate around the screen and we can do different things. So it's a dual purpose there. The power on and off button, you'll see that that also serves as a dual purpose now. Not only will it power it on and then turn it off, but we can also, that's how we input the number of strokes of grease that we have added as we're out collecting the data. Of course, the headset jack, and then moving over here to the bottom right picture, you can see the LED light. And then moving up, you have your recharge plug, and then finally your BNC connector for your magnetic mount transducer. Okay, so when it comes to the location where we want to put that magnetic mount contact probe, if you've been through any of our training classes, obviously the closer we can get to the bearing as possible, that's going to be the preferred location. You also, along those same lines, the nature of high-frequency sound is that it doesn't travel very far from the source, so obviously the further we get away from that bearing, the more that sound is going to attenuate and we can drop in decibel level. So ideally, closest point to the bearing as possible is going to be preferred. In cases to where you don't have access, good access to, say, the grease fitting or the motor housing itself, you can use the included docking station, which you can see there. The second picture is going to bring it up a little bit closer so you can see. It's just a repeatable, consistent place where you can mount the magnetic mount transducer. Now, we prefer to make contact directly to the motor housing itself or the bearing housing. Again, closer to the bearing is going to be more ideal. So you can see here in this picture, we're just simply making contact here, again, close to the bearing housing there. I've also seen people, if they have the grease fitting extensions that extend up just a couple of inches above the motor housing, you can just simply pop the magnet on the side of that grease fitting. You have to think, that grease tube acts as a waveguide, so that sound has a much easier means of travel via that grease tube. Plus, if you're using the grease fitting, again, it makes it more repeatable. We're testing in the same location every single time. And with any of our Ultraprobes, you always want to make sure that you have the headset on at any given time. Some people say, well, I'm watching the decibel level, why do I need to wear the headset? Well, when you're listening to the bearing, you're going to hear if the bearing is in some sort of failure mode. A bearing that is in a inner race or outer race or has some other kind of fault is going to sound a lot different than a bearing that just needs to be lubricated. So having that headset on is always going to be important. So some basic operation. Obviously, your power on and off button, if you just press it and that's going to turn it on. Now when you go to turn it off, you do have to hold it in for approximately 5 seconds, then eventually it's going to power off. And then the sensitivity spin and click dial, again, that's a dual purpose. So not only can we adjust the sensitivity, but it's also going to be how we navigate around the screen, and it's going to be how we can do some different things along the function bar that we'll talk about. Recharging, it does have that polymer battery, so on a full charge, you should easily expect around 7 to 8 hours of continuous use out of it. So again, very similar to some of our other Ultraprobes as far as the battery life. And then your BNC connection, just make sure that the magnetic transducer is properly connected. So now, moving around the display using the sensitivity spin and click dial. So here's a little closer in shot of that main display. So we're looking at 3 different things currently on this particular screenshot. So we can see here we have the S equals, and we see a number there. That's the sensitivity where we have it set. 0 is the lowest, and 70 is the highest. Keep in mind, though, that the sensitivity is going to have no effect on the decibel level. The sensitivity, you can compare it to a volume, but really we're just trying to dial it into to be able to measure how much noise is being generated from that bearing. Think about it as if you have a bearing that's in a really good condition, maybe it's properly lubricated, brand new bearing. That bearing is going to not be making as much sound as a bearing, say, that's either over lubricated or in some sort of failure mode. So that bearing that's in the good condition, you may have to turn the sensitivity up a lot higher to be able to measure that sound, versus the bearing that's making a lot of noise, you're not going to have to turn that sensitivity up near as high to be able to register a decibel level. And then moving over to the right, we have the record number. You'll see in this case 001, so it lets you know how many records have been stored, and we have ways that we can navigate around and navigate through the route, either forward or backwards. And then finally the function bar down in the bottom of the screen. But basically whatever is blinking is what we're adjusting. So if we're currently adjusting sensitivity, if I want to get over here to the record number, I just simply press and release the sensitivity dial, and that's going to move me over to the record number. If I press and release again, that's going to move me down here to the function bar, and there I can scroll through some of the different functions there, some of the different menus. And then if I press and release again, that's going to bring me back to the sensitivity. So again, the press and release of that sensitivity dial is what's going to navigate me around the screen. So within that function bar that you saw down at the bottom of the screen, the selections that are available at any given time to you are the following. We have the display 1 and display 2, so that's our 2 display settings, which we'll talk about. We have the store record, so that's what we would use if we were ready to then go out and collect data. We have SD info, so that's going to give us information that's currently on that particular SD card. And then finally we have the setup menu. So we'll go through each one of those, I guess, sub-menus within the setup menu. Some of them are just kind of personal preference things. Some of them are just as simple as set date and time or headphone volume. But we'll go through each one of those. And again, all we do is we just simply press in the sensitivity dial until the function bar option is blinking, and then from there we can turn left and right that sensitivity dial, and that's going to scroll through these 5 options here: display 1, display 2, store record, SD info, and then setup menu. So our 2 display panels that we have that we can set this up. First of all, display 1, it's going to show us the sensitivity value. It's going to show us our record number. If we need to load a route into it from DMS, that's going to show the machine and the point name, the decibel level, which you can see again similar to some of our other Ultraprobes. You'll see this blinking arrow pointing to either the right or to the left, letting you know where you need to set the sensitivity. Once you've got the sensitivity into range, that's where you'll see your decibel level. And then the function bar. And then display 2, we'll see the sensitivity value, the record number, but then we also have this little intensity bar graph or intensity meter that will then appear, and that's only available in display 2. And then again, we also see the function bar. So either display, we see the function bar to where we can then set up and switch back and forth between display 1 if we need to and display 2. So that's available at all times. So storing a record. To store a record, we need to make sure that store record appears in that function bar area there at the bottom of the display. And what you'll need to do is just simply press, and just hold in for just a second or two, and then release the sensitivity dial, and then that's when you'll see store record confirmed on the display. So as far as storing the record, it's just as simple as that. Make sure you've got store record down at the bottom of the screen, and then just press, hold, and then release the sensitivity dial, and you'll see your store record confirmed. Now, if we need to change a storage location, so let's say we've got our route loaded into it, and let's say we get to a particular piece of equipment that we need to collect data on, but let's say that piece of equipment is not running, it's not in service. So we really don't need to collect any data on that. So using that sensitivity spin and click dial, I just keep pressing and releasing that in, and then eventually the record number is going to blink or flash. So when we see that record number blinking or flashing, using that sensitivity spin and click dial, we can then advance forward and skip over those points. And then we can move on to the next asset where we need to go out and collect the data. And so we've skipped over the points on that piece of equipment that wasn't running. And we can do the same thing if we need to scroll back and correct ourselves. So if we're halfway through the route and we realized that back at motor 2 we took the readings in the wrong location, or maybe we even took the readings on the wrong asset, we can scroll back to those points and then go back and correct ourselves. So it'll overwrite that bad data with the good data. Now, if we need to view data stored in a record number, what we're going to do is we're going to press and release the sensitivity spin and click dial until that record number blinks, like we were going to do if we were advancing forward or scrolling back to correct ourselves. And then we turn the sensitivity spin and click dial back to the desired location. And what's going to show here is, you can see here we've got a decibel level reading here. This is the baseline dB that has been stored for that reading. So that information comes over from UltraTrend DMS when we load a route into it. So we can see the baseline dB for, in this example, the motor 2 motor inboard point, and in this case was 33 dB. So whatever the baseline is for those points, that's what's going to bring over from DMS. Okay, the SD info. This basically gives us some options to see what's on the SD card. How much space do we have left? We can display all the files. We can delete all files if we need to. Most of the time, that's going to be done at the computer. You can clear it out on the computer before you load something else on it if you want to, just for proper SD card maintenance. But if you need to view whatever's on the SD card on the instrument, this is where you would do that, and that's underneath the SD info located in the function bar. Okay, so our last menu that's on the function bar is the setup menu, and that's going to take us into a total of 18 different settings that we can use to set up and do different things with. Again, some of these, as I mentioned, are kind of personal preference kind of things. Some as simple as just setting the date, setting the time, the date format. But others are going to be more important. So as we go through these, I'll kind of highlight which ones I think that you would probably use the most. Okay, so we do have this feature here underneath the setup menu for the add and remove SD card. Really it's kind of a best practice to where if you're going to remove that SD card, if you're only using just one SD card, just simply just power off the Ultraprobe 401. Where you would probably use this would be the scenario that I gave you, to where if you were using multiple SD cards. So if you were out and you were through with collecting data on one route with one SD card, if you wanted to insert a new SD card with a different route, you could go in here without powering off the 401, and we could just do our add and remove SD card, take the one out that we're through collecting data on, put in another SD card that has a different route, and that's going to load whatever's on that SD card. If you're only using just the one SD card, if you're not doing multiple routes at any given time, then you may not be using this one. But best practice is just to go ahead and power it off. But if you need to change out, while you're out collecting data, this would be where you would do that. So then, storing the before and after reading, and again, this is probably going to be important to you if you've got a point that's, say, currently in the lubrication alarm or the low level alarm. If you want to take a before reading and then an after lube reading, this would be how you would do that. So in the setup menu, this has got to be turned on in order for you to do that. So you can see here store before and after, and then you would just select on, and that's what's going to allow you to take that before lube reading and then the after lube reading. And then the add lube amount. Now this is the concept here really is going to have to be used with a calibrated grease gun, and we kind of realize that, and you say that to some people and they say, oh yeah, we've got our own process, we've got a way that we calibrate our own grease guns. And then you say that to other people and they have no idea what you're talking about. But really, you've got to know that at a full pump of grease, how much grease is coming out of that nozzle, how much grease is going to go into that bearing. So when this is turned on, it's going to allow you to input the number of strokes or pumps of grease that were added when storing the data. And again, you really need to make sure that your grease gun is calibrated. And, again, it's going to be at a full pump of grease. So, really, we could do a whole webinar on just lubrication best practices, and this will probably be covered with the 3 that we have coming up for the month of February with Descase. So really, there's whole, really lubrication best practices, and this is part of it, is calibrating the grease gun and knowing how much grease is going to come out of there when you put in a full stroke. But what our concept here, our thinking is, you're going to be able to then track, say planned number of pumps of grease compared to actual number of pumps that were entered. So as an example, let's say that you have a PM that says to go to a particular motor and apply 10 shots of grease. Well, so the planned would be 10 strokes, but let's say using ultrasound, let's say after 6 strokes of grease, the decibel level dropped back down to the baseline. There's no reason really to put 4 more strokes of grease into that bearing. At that point, you're really probably going to start to over-lubricate it. So if the planned was 10 and the actual was 6, then you can track that, and maybe you can start to adjust your PMs to where it's more condition-based. So we're now only applying the amount of grease that ultrasound tells us, hey, this is enough grease, compared to what you may have been using before. And we've seen that, and you've probably seen it firsthand in your facility, but the tendency for time-based lubrication is to over-lubricate. So that's going to be important. I've got a couple of screenshots coming up of the updated fields in the latest version of the UltraTrend DMS software, which is available. It was just posted this morning. But you can actually input the cost of that grease. So again, we're able to track our amount that we're using, and then we can also track how much that grease is costing us in a dollar amount. You just simply enter that into the DMS software. So one more thing here, what will happen is when this is selected, the planned number of strokes will display intermittently between the record number back in the main display. So when we have that turned on, right here in this example here where it says 006, that would intermittently flash to whatever the planned number of strokes would be. So what we would want to do is we would want to adjust the sensitivity to get our decibel level reading. Press and release the sensitivity spin and click dial until the 00 here is blinking. So that's going to represent the number of strokes of grease. And this is where we'll use the power on and off button. And what we'll do is we'll just kind of quickly press and release the power on and off button to input the number of strokes or pumps of grease that were added. So if you entered 6 strokes, you would just kind of quickly press the on and off button 6 times, and that would input 6 here. So then once the number of strokes and pumps of grease have been entered, then you'll press and release the sensitivity spin and click dial to then store the reading just like you normally would. And so it'll store the decibel level reading along with the number of strokes of grease that were added. And again, just to kind of highlight here, the latest version of UltraTrend DMS, like I said, it was just posted this morning. So as of the date of this webinar, February 6, 2015, the latest version is DMS 5.4.5, and that's available for download. I know on the U.S. website, not for sure on the international sites, but you could get that directly off of the main U.S. UE Systems webpage. So you can see down here for the bearing application, we've added some fields here for actual strokes, injected mass, so that's where your calibrated grease gun is going to come into play, where you know how much grease is coming out of that nozzle per stroke. You can input here the planned number of strokes of grease, your grease type, and then so now we have the mass per stroke. If you want to input the viscosity, you can do that there. So then here's the cost per mass. So here's the cost per pump of grease, how much it's costing. So then it will then calculate the injected cost. And then here is, currently this is what you're able to do. Now we realize that as people start to use this, we're going to get some feedback from the field, and to be honest, when we make changes to, the instruments, when we get ideas for instruments, ideas for the software, a lot of that information comes from the actual users, the people who are out in the trenches using the equipment on a daily basis. So, we realize as more and more people start to use this, we'll then change some of the reports that you're able to generate. But for instance, this chart right here, we're looking at the actual strokes of grease per the and comparing that to the planned. This should look familiar to most of you. This is what we would typically see when we're plotting the our data. So we've got 6 historical readings here. We're plotting that against a baseline and a low alarm and a high alarm. And then we've also added temperature here. And if you're not sure how to do this, what you would do is you would just click on whatever point over here in your hierarchy, whatever point you're interested in seeing the trend of. You would click on your history tab here, because whatever is selected in the history tab is going to be what's going to show on the chart. So in this case, you would just click on history. Your choices would be over here on the right. You would just select temperature, move it over to the left. You would select actual strokes, move it over to the left, and then planned strokes, move that over to the left. And then when you click on chart, again, whatever you've selected in the history tab, that's what's going to show up on the chart. Okay, instrument setup. Similar to the 10 and the 15, we have manual and we have automatic. So what's going to happen is you're going to take the initial data in the manual setting. So with the manual setting, we're going to be changing sensitivity. In some cases, we may even need to change the frequency that we're using. But we're going to be, changing some of the ways that we're storing that data. So what will happen is the next time before you load that route into the instrument again, you would just simply set the instrument setup to automatic. So when you load that route in there, it's going to automatically set the sensitivity that was used. It's automatically going to set the frequency that was used. And then it's also, probably most importantly, it's going to bring over that baseline information. So it'll bring over the baseline dB. It'll bring over the planned number of strokes. It'll bring over, again, any sensitivity settings. So you just simply take the initial round of data in the manual setting, and then before you load that route in again, you just make sure that you change it to automatic, and that's going to automatically set it and then bring over anything else that you may have entered into the DMS, such as the planned number of strokes of grease. Default settings. Any of our instruments, the digital instruments, are going to have a default setting. So if you ever think that you have just really messed something up and you really just like to start over from scratch, you would go here to the default settings and you would change this to yes. And when you do that, that's going to clear the instrument out and reset everything back to the factory defaults. Then the user sensitivity default. In our case, the factory default sensitivity setting is 70, the highest setting. If you don't want it to be 70, then this is where you would change it. So then if you do set it back to the factory defaults, it's going to keep your user sensitivity default setting. As far as the factory is concerned, our default sensitivity setting is 70. So then the user frequency default. As I mentioned, the Ultraprobe 401, we can adjust the frequency anywhere between 20 kilohertz and 100 kilohertz. But as you know, we have really it's really about 4 different frequency settings that you need to remember for the different applications. The frequency setting that we recommend for bearings and mechanical inspection is going to be 30 kilohertz. Now that's not set in stone. We have some people that use different frequency settings for bearings, but as a company we recommend 30 kilohertz. We believe that's just where you get the most clear sound for the bearing, but really you just kind of use it to what's appropriate for you. But we recommend 30 kilohertz, and that is the factory default frequency setting for UE systems is 30 kilohertz. Now we have frequency adjust. So what this does is it allows the user to adjust the frequency. As I mentioned, the factory default frequency setting is 30 kilohertz. So if you don't want people adjusting the frequency, then you would just simply, this is where you would do it. So this is where you would actually adjust the frequency itself. So if you needed to set it from, let's say, 25 or even 20 kilohertz, this is where you would do that, and that's the frequency adjust setting. Okay, we have our display response, and your three choices here are going to be slow, medium, and fast. And it's basically the speed of the response of the dB on the display. You may find that a fast setting is just too fast for you. Maybe you want to change that to either medium or slow. This is kind of one of those personal preference settings, but again, you have the ability to change how fast that dB is changing on the display. We have a headphone adjustment here. The factory default headphone volume setting is 95%. I know for most of you, you kind of use that sensitivity as kind of like your volume, but even if you find that it's still a little too loud in the headset, you have the ability here to adjust that headset volume from 0 or to 99%. And then enter the inspector ID. Now this may be important to you, so that way we know who collected the data for this particular route. So you've got up to 3 characters here, 3 alphanumeric characters. So again, using the sensitivity spin and click dial, we can just simply scroll through the alphabet there, and you can enter in your initials, your employee ID, however you want to do it. And then when you download that data into DMS, that'll populate underneath Inspector ID. It's basically just going to keep track of who collected the data for that particular route. And then we have set date and time, just to make sure that the data is properly collected for accurate trending. And then we have date format. So we have either month, day, year, or day, month, year. In this case here, we're showing month, day, year. And then our calibration due date. Now we recommend a recalibration once a year. And if you're not sure when your instrument is in need of calibration, that's going to show up right here underneath calibration due date. Okay, the next one that we have is going to be of use to you if you have multiple Ultraprobes in use. And I'll give you an example here, but it's going to be the dB scale type select. And your 2 choices you have are relative and offset. And again, this will only be used when you've got multiple Ultraprobes being used to collect data on the same routes. So the example that we have here is if you have an Ultraprobe 15,000 and you're using the Ultraprobe 401, you may get different decibel level readings between the 2 instruments. In the next scenario that I'll give you, you will get different decibel level readings. But let's say you're using the magnetic mount contact probe on the 15,000 and then you're using the magnetic mount of the 401. You may get a difference of 1 or 2 dB between the 2 instruments. So what you would do is if you wanted each instrument to read the same, or if you wanted them to match up, you would come here on the Ultraprobe 401 and you would change the dB scale type from relative to offset. And then the next menu that we'll talk about is going to be the dB offset value. So then you would just go into the next menu, which is that dB offset value, and you would then enter 2 if they were reading 2 dB apart. And that way now your Ultraprobe 15,000 and your 401 are going to read the same. Now another scenario is going to be if you're using any other instruments, say a 9, a 10, or a 15, and let's say you're using the stethoscope module to collect the data, and then you've got the magnet with the 401. You will get different decibel level readings between the stethoscope module and the magnet. The stethoscope module tends to be a little more sensitive than the magnet. So again, in this case, you would go into the dB scale type select, change it from relative to offset, and then you would go into the next menu and set your dB offset value to whatever that difference is. So that way, again, both instruments are going to read the same dB. Now, if you have the idea of, let's say you already have, say, a 9, a 10, or a 15, and you're going to use the Ultraprobe 401 for your greasing. And let's say you want to take just your alarm group, so you have your, in DMS, once you download that data, and once you kind of, set your baseline and your alarm levels, you have a little subgroup in there that's called points currently in alarm. You can take just that alarm group and load that into the Ultraprobe 401. There again, if you've taken those readings with the 9,000, the 10,000, or the 15, using the stethoscope module, again, you're going to get different decibel level readings with the magnet, so there again you would need to change your dB scale type to offset and then just set the offset value to whatever the difference is between the two instruments and modules. And that is the next menu, is if you do change the dB scale type to offset, this menu here, this is where you would enter in that offset value. And your choices are 1 through 15. You're not going to get a greater than a 15 dB difference between attachments. It's not going to be that much. But whatever the difference is, you would just simply enter that value in there. Okay, and then finally we have the battery level. So this is going to show you what percentage of the battery is left. And then our last option is going to be just system shutdown, and that'll power it off. And then the last screen here, we've got just some basic technical specs. And again, this will be posted on the website. You can also get this off of the product, the Ultraprobe 401 page on our website. Okay, and that's going to be it. Maureen, do we have any questions?
We do. We've got quite a few, so we'll try and power through these. So Adrian, did I hear you mention you can use the new Digital Grease Caddy with the Bluetooth headsets?
You sure can, and again, you'll just need that, the optional Bluetooth transmitter, so you just simply plug in the Bluetooth transmitter into the headset jack, and then it'll connect up with your wireless headset.
And can those Bluetooth headsets be used with our other Ultraprobes as well?
Yes, that's exactly right. So that transmitter will work with any other Ultraprobe. Now, again, the 15 has it built into it, so there's no need for an external transmitter. But yeah, even with the Ultraprobe 100, I mean, you could plug it into the headset jack, and then it'll connect up to a wireless headset.
Perfect. Well, that was a little bit of a self-serving question, so now we'll get to the real ones that folks are asking. Okay. It's only fair, right? So how would someone know if it's a lubrication problem they're hearing or a failing bearing? What's the difference there?
Yep, so that kind of gets into ways that we teach people to set baselines and alarm levels. So really the preferred method of setting a baseline when it comes to using ultrasound is going to be through an approach what we call the historical method. So in the DMS software, you set up your route, and then you just begin to go out and collect data. So you're building a history. As part of that process, it wouldn't be a bad idea to take a grease gun out with you. So if you're watching the decibel level as you're applying grease, if the decibel level drops, then that's probably the reading you want to take and use as the baseline. So that bearing, as an example, would already be in need of lubrication. So if we greased it, the decibel level dropped, that's probably the reading we want to take and store as the baseline. So whatever your baseline is, in the DMS software, you have the ability to input 2 alarm levels. You have a low alarm and a high alarm. The low alarm, typically we're going to use 8 dB above the baseline. That's going to represent a lack of lubrication. And then 16 dB above the baseline is going to represent kind of that next stage of failure for the bearing. Obviously, if you have a 10 or a 15 and you have the ability to do the onboard sound recording, that's really where we start to get into the diagnostics, and that's really where those bearing fault harmonics are going to show up the best. It basically just kind of moves it from just comparing the decibel level at different points to now we're actually we're painting a picture of what it is that we're hearing, and that's really the only way to determine is it just a lack of lubrication or is it a more severe fault or failure.
Yeah, and that's a good answer in the time that you've got here to provide that info. But if people are interested in more detail and more explanation on kind of all those the principles behind utilizing ultrasound for your lubrication, we do have some recorded webinars on our website that you can take a look at to learn a little bit more, and tons of articles and things like that. So definitely take a look there if that's of interest and you haven't been able to catch one of these before. So a couple different folks asking about the different types of grease guns that you can use with the Digital Grease Caddy. So one was, can you use this with power grease carts?
Yeah, it's basically, it can be used with any kind of greasing apparatus out there. The only thing that we're doing is we're just listening to the bearing as we're applying grease. So yeah, again, battery operated grease guns, pneumatic grease guns, grease carts, pretty much anything. All we're doing is just listening as we're applying the grease.
Perfect. You just answered a couple people's questions all at once. That's great. Okay, then someone's asking about an intrinsically safe rating. Is that something we've got on this unit?
No. For anybody that's been through the process of having something rated to be intrinsically safe, it's a very, very long process. It took us quite a while, for those of you that have been around our equipment, it took quite a while to get just the Ultraprobe 9000 intrinsically safe and ATEX rated. So currently, this instrument is not rated intrinsically safe.
All right, and another popular question is the price tag on this new Ultraprobe.
Yep, it's going to be, well, it's right at $4,900. So it's not terribly expensive for what you can do with it, and then really, again, when you get into the tracking, how much lube we're using, the cost of it, it's going to become similar to the way most people justify the cost of purchasing an Ultraprobe now, and through compressed air and gas leak detection. We really see this as another way of showing, real dollar cost savings, from again, using less lube, not only amount-wise, but also putting a dollar amount to it. So, it's going to become a pretty powerful tool for any lubrication, reliability-centered lubrication.
And now with that, the software that you mentioned, our DMS software, that comes with it, right? Mm-hmm. So it's available on our website for you to use. And someone's just double-checking that, obviously, can that software, obviously you use it with this new Digital Grease Caddy, but that same software program can be used with any of our products. Do you want to?
That's right, yeah. So it's the UltraTrend DMS, and like I said, we just posted the most current up-to-date version, and that's 5.4.5.
Perfect. Okay, and let me just look here. There were a couple more I was going to ask here for folks, and obviously, if you're sitting there, feel free to type in some more questions. Someone's just kind of, I guess, doing a little comparison. If they've been utilizing vibration to monitor the dB levels, what's kind of the upside, the downside, as in relation to utilizing ultrasound instead? Maybe you can speak to that just a little bit.
Yeah, so as a company, we've never told people, you don't need vibration, use ultrasound. But, a multi-technology approach is really, it's really what world-class reliability programs, that's their approach. But there certainly is a change in mindset out there to where ultrasound is going to give you that earliest indication of a fault. And that's where ultrasound is really good. It shows up very nicely in your FFT and your time waveform views of those early stage bearing failures. Now what happens as that bearing continues to run and the condition gets worse, those harmonics tend to get masked in ultrasound as that failure gets worse, and that's where your vibration comes in, because you can actually separate out and look for those faults. So again, you can kind of make your own decision, but again, there's a change in mindset to where ultrasound is going to give you that early indication of a fault. I guess another advantage that we hear a lot from the field is it's very easily used and it's very effective on slow speed bearings. We have people using ultrasound on applications as low as 2 and 3 RPM. I was just in a tire manufacturing facility a few weeks ago. They have an extrusion process that turns about 17 RPM, and we very easily identified 3 bad bearings out of like 20 that we listened to. So it's very easy to use on slow speed applications.
And I love when slow speed bearings get brought up on these webinars, because it gives me a chance to plug that we've actually got a presentation at our upcoming Ultrasound World conference taking place in June that's solely about the success one company had with utilizing ultrasound on their slow speed bearings. So just a little plug there, but you teed that right up for me. So another question, can we use this to measure dB values while greasing bearings connected with remote lines?
Yeah, so what you'll need to do in that case, and remember I mentioned that high frequency sound doesn't travel very far from the source. So the further we are away from that bearing, that sound is going to drop off, or that decibel level is going to drop off. Depending on how far away it is, if it were my facility, what I would do is I would install the RAS, of the remote mounted sensors, which you can get those on the standard lengths of cable are 25 feet or 50 feet. We can make them shorter than that. We can make them longer than that. So you would just simply, go in, it's a stud-mounted sensor, run your cable back out, and then, of course, you've got your grease fitting, coming out, and then you would just simply plug in that RAS sensor directly to the Ultraprobe 401 and grease that way. That would probably be your best bet.
All right. Another one. What effect will working in weather that is around 0 degrees or the teens going to have on this unit? And I got to say, I won't complain about being cold in my office anymore.
Well, to be quite honest, it's probably going to have the same effect on whatever else you're probably already using. You've got the holster that you can keep it in. You can see here on the specs that the operating temperature is the lowest is 32F. It's just like any other piece of electronic in those conditions. You just kind of have to be aware of, what it will do to it. The only issue that we've really seen is when you get up into some of the higher temperatures, with that being, in like an LCD display, that screen will have a tendency to go a little dark on you when you get into those higher temperatures. But, through basic, battery maintenance and charging and anything that you can do to kind of keep it insulated when you're in those cold weather conditions, that's certainly going to help.
You just get some of those heated hand warmers or something, right?
Yep.
Okay. So back to the slow speed bearing, someone chimed in. I guess we got people thinking about it. Is there a size limit when it comes to slow speed bearings? In other words, is this practical with smaller slow speed bearings like those on a conveyor belt?
No, it's ultrasound doesn't really have any effect, or the size of the bearing doesn't have any effect on the ultrasound. Now, what will happen is when you get into some of those slower speed bearings, if that bearing is good, it may not even register a dB, just simply because there's nothing in there creating any kind of noise. But what will happen is every time, let's say a fault starts to occur, every time on that rotation, it may be just as subtle as a click or a pop or a screech. And of course, you're going to hear that, and then you would see, just a slight increase in the decibel level there. But yeah, certainly, we can use it on any size bearings, pretty much any speed of bearings. The ultrasound, it's not affected by how big or small the bearing is.
All right, and we're going to do this as the last one, and I promise somebody actually typed this one in, so it's not us kind of teeing this up for you. But can you use this digital Ultraprobe as part of an ongoing lubrication management program on a monthly basis?
Yeah, and that's exactly what it's designed for. It's designed for people to, again, move away from just simply time-based lubrication, which, again, the tendency for that is to over-lubricate, to move more towards condition-based lubrication. And again, the simple concept is just friction. So when we have a bearing that's in need of grease, we've got a slight increase in the decibel level. So what we're hoping to see is when we're watching the decibel level and applying that grease, it's going to drop back down to a more normal kind of baseline or steady level, and then we stop greasing. It's still going to let us know that, let's say we get out to a point and let's say we apply grease. If that bearing is already sufficiently lubricated, as soon as we start to pump more grease into it, that decibel level is going to start to gradually increase. So again, going back to our PM, let's say, says go to a piece of equipment and apply 10 strokes of grease. Well, if after 4, 5, 6 strokes of grease the decibel level drops, then there's no reason to put 4 more shots of grease into that bearing. So yeah, it's really designed to really move more now towards condition-based lubrication rather than just solely time-based.
Perfect. Well, we are running up against the clock here, so there were still a couple other questions, but we will be sure to get in touch with those folks offline to get those things answered. But obviously, a lot of interest here around lubrication, and so it's good that we have devoted the entire month to that topic. So I guess we were all thinking the same thing. So thanks for all that information, Adrienne. And just to kind of wrap up, obviously, our website, we've got just a ton of information on there. Obviously, everything you need to know about with bearings and lubrication, but the other applications as well. Recorded webinars where we've talked about these things are all up on there. So take advantage of what we've been able to compile over the years, and take a look for what it is you're looking for. And if there's something you can't find, then let us know, and we'll be happy to dig it up for you. We always like to make sure you guys know how you can stay connected with us in between these webinars. We've got our Ultraprobe users group and our Reliable Asset World group on LinkedIn. Great place to ask questions and kind of share feedback back and forth with your peers. So take advantage of those. We're on Twitter. We've got our blog. So lots of ways for us to all kind of stay connected. And then our upcoming dates. So obviously, if lubrication is something you're interested in, something you guys are working through at your facility, we've got lots of great stuff coming up the rest of the month. We've got Desk Case is actually going to be presenting the next 3 weeks of webinars for us. Next week, Mark Barnes with Desk Case is going to be doing lubrication, cost or opportunity. Then Jared Pottinger is going to do Deploying the Basics, the Importance of a Solid Foundation for Lubrication Success. And then Jason Kopczynski is going to round out the month on Friday the 27th with Where the Rubber Meets the Road, Executing on Precision Lubrication. So lots of great topics there. Sign up for all 3. 1 of them, 2 of them, however many you can make, and of course we'll record all of those as well. We're also going to do a bonus webinar on February 25th where we'll go through the DMS software, review any of the changes that we've made to it, and so if you're using the software or if you haven't started using it, that'll be a great session for you to join in, and obviously we'll be sending out invites for all of these things. And then of course our 2 conferences, Ultrasound World and Reliable Asset World, coming up June 2nd through the 5th in Clearwater, Florida. I know that one gentleman who's working outside in the the teens would probably love the idea of a trip to Florida on his calendar to look forward to. So check out our websites and see if you can make it to those events, and hopefully be able to join us for some of these webinars we've got coming up the rest of the month. And with that, I'll leave our contact information up, let you all go and enjoy the rest of your Friday, and have a great weekend, and hopefully we'll see you all back here again next week. Thanks.